Then, so this is how, if you get a space of a map in XR, what is exists in XR is like the environment and the people who enter that environment. That can be divided into two parts. In XR, it is basically avatars and agents. Avatars is your entity. Agents are someone that is like non-playable character or NPCs, and there are some objects. So how AI is used to build XR is to build or bridge this gap. In real world, we used to understand environment, we used to understand how people think, and how what are the objects tracking. So your if you go on a higher speed in the Adelaide traffic, the camera captures you, so that is where you track your object speed and stuff. That is in reality. Similarly, in XR space, how objects are tracked and what is the thing that gives you intelligent interactions. And the environment, like your IoTs, and the moment you enter your room, your aircon adjusts the temperature. All these things needs understanding of people and the environment. Similarly, in the XR space, when people are crowded together or people are discussing something, we need some intelligent actions behind that. So to improve those XR experience, that's where AI is helping us to accelerate that user experience. So it basically covers three parts, or the I would say three major parts. That is realistic replication of real world. Can we create a digital twin of your environment space? So people are joining in Zoom, they can see the thing. But imagine if the Zoom is in XR, so that we all there in the XR space and it's modified. In that one, to create that 3D scene and create that gesture interactions, you need AI tools to help improve that user interaction. Then modification of real world. That's where comes the augmented and mixed reality space. If I don't like the color of the chair, I can just change the color by visually changing. So that is modification. Then generation of synthetic world. So imagine the presentation. If I just make, can I have a cup of water over here? And the LLM understands and brings a cup of water in my hand automatically to give a ink present, or like a presentable boundary object for the discussion. So that is where AI is also used to create like something synthetic, so that it enhances user experience. So this is a space where state of the current art, where XR and AI merges. So first one is people use different kinds of AI models to create XR worlds. Second space is AI to understand XR users in XR space, because in XR you are limited with interaction facilities. This is where AI augments XR by helps us understanding users. The third one is to support interaction in XR. Fourth one is in interaction with intelligent virtual agents. And last one is how we can use XR to support AI as a instead of forward loop, there is a closed loop as well. So I think most of the projects that Alison discussed in Alison and Mark introduced over here, it falls under one of these five categories. And here we'll go through each categories, how like different kinds of AI models helps each XR experiences, and just try to, because I'm going to throw some words that might be not familiar to you or familiar to you, just have a familiar understanding. Then if you guys want to ask more details, just let me know, or I can share more materials on that. First one will explore how AI is to create XR world. So there are, if in XR world, there are four categories: the environment, avatars, agents, and XR objects. First one is the environment. So there are two ways, I would say, in environment. One is tracking the real world object and creating a digital twin in the XR world. So that is where the simultaneous, like imagine creating a University of South Australia campus in XR world. You need to know the accurate routes and accurate mapping of all the buildings and things. For that, we might use, what we do is we take a camera, compute, stitch all them together, create a 3D scene, and export it to a XR space. So those way of stitching and mapping the realistic routes on of the campus needs some kind of a computational design or computational algorithms. That's where AI comes to play to help you create that mapping and localization. The second part is creating that realistic virtual content. Currently, these diffusion models are the ones that where you get text to images, where you generate image things. That those are the ones that can helpful in XR world. You can take a three picture of this classroom and ask it to create a 3D scene and export it in XR. And this part is where, because in XR you need, it depends upon computational intensity. Sometimes if you have experienced any things, it's not like most of the objects you would see, it's more like animated. You need a physically realistic objects where when the user is looking, you need to have appropriate shadow, otherwise it reduces the realism. So that's where couple of people use certain AI models to understand where users is looking and compute a physical specific physics specific object illumination, so it enhances more realism. And the third one is of course increasing the quality of the image. So based on where users gaze is looking, you can improve the number of points that are there, so that increase the quality of the data or quality of realism. The final part is the uh, segment anything. This is very famous for augmented reality applications where you use AI models to instantly track all the objects and mobilize everything. So there are current AI models such as Nerf and 3D Gaussian plating that runs like in the device that can render whole 3D and give you a accurate mapping of where the chair is. How do I move the chair if the chair is in this one? How to track the. So this could be very useful for any augmented reality application where it can accurately say, oh, I'm having a cup of water or a plate over here. If I track it over here, I can make my sandwich looks more nice and have more veggies. That gives you a thing. So similarly, these are the applications currently where AI used to create that segmentation and to understand users environment in a much more localized form. And you can use basically to create more personalized experiences. The second part of creating AI to understand XR world is creating avatars. So I think many of you guys would have seen a Vision Pro trailer where you see a uh, probably almost realistic human character speaking to the person. So I would say that is the most accurate where you want to, because in XR world, one of the disadvantages, you either create an animated character version of it. If you want to improve the realism of XR world, you might need to create your photorealistic way. So that is where people are working currently on developing models that increases the realism of avatars in the XR space. So this is where this object comes. This model comes, and another part is you don't need just the uh, creating a photorealistic one. You also need to track their dynamic movements, because humans are dynamically communicate via body language and their gestures. So we might have to create like a accurate model with the minimal input modality, because in an XR world, all you can see is you have a tracking in your controllers and you have a camera within this limited input modalities. How can you track all the uses movements that dynamically changes? That gives you a problem. That's where AI comes handy, because they're able to generate and they're able to understand with minimal data and get you through the output. The third part of this one is creating agents. So not only that we need our own avatars to be created, if we have a AI character that is intelligent, that is like a personal assistant. If someone if I want to skip my meeting, I can just send my AI NPC character to that meeting and attend the meeting for me and come to me and say, oh, these are the things that we discussed. So that is where this agent comes to play. Even if if not, you are not wanted, and if you need to know about it, these agents always exist in XR space that can guide you XR spaces. If you're new to a place where you don't know, it can guide you all these one. Or sometimes people are investigating on mental health applications as well, where it can give you prompts and it gives you a guided experience that may reduce your anxiety or stress in a certain situations. So that's where AI is helpful, because these agents needs to be have a bit of realism in their behavior. Otherwise you would find it's AI and becomes falls under uncanny valley. And the last one is tracking XR objects. The main reason for tracking XR object is very essential, and how AI models are used is, uh, if you want to make a computationally intensive, if you have a if you have a environment and which is computationally intensive, and if you load it all the way to the users, that going to have a like a delay. So people are smart, or what they use is, if the user is looking at that chat, it just increases the uh, uh, computational intensity of that only object instead of the whole environment, because users focusing on that, so it makes it more realistic. So this way, if we track objects and we know where users are seeing, this makes the design and experience much more smart. So that's where AI, uh, uh, that's one of the way AI is used to track objects. That is what rendering and modifying objects. And these are a few examples I've shared. Now we'll go under how AI is helping us to understand users in XR. So the main idea for understand, because we are the ones who are using XR. So if our experience in XR is not very great, then we wouldn't able to or it would be a very false information in XR, or we won't be able to join XR. So that's where, if you have seen the Google, uh, when you're going for a shopping and Google automatically, like, you upload your photo and Google can check your design. So that is one of the smart way where Google runs your personalized body pose, or understands your personalized body and adapts a shopping experience for you. So this, if you can imagine, if similarly for AR or VR or XR experience, this experience can, like, how having personalizing users can significantly improve the XR experiences and the interaction more intuitive. There are primarily three ways AI is used to understand in XR. One is predicting VR sickness. That As Mark introduced, the VR sometimes induces a lot of virtual reality sickness, like because it doesn't match our reality. So that way, if you can able to perceive users, understand wherever users are going for the cyber sickness or VR sickness, and it can modulate the environment accordingly, that reduces the bad effects. And then predicting users characteristics and intents. So if I'm about to go sit on this chair, the VR experience also, or AR experience, automatically adjusts based on that, the intent based on that. And the third one part is mainly to they use eye tracking and gaze analysis, that is for object rendering and as we discussed before, modification, as we discussed before. So the predictive models are, these are like I wouldn't say traditional, these are the classical machine learning models, where we collect their EEG or the input model. It can be anything basically, their physiological signals or behavioral signals from IMU, all these stuff, and train a model. What is the train a model to predict their VR sickness, so that it can dynamically adapt its view based on users looking. And the second part is, if in VR, because we don't in a VR scenario, we don't have a object physically present. It's more all digital. So how do you know which object they are going to interact with? And based on that interaction type, can I able to move the object towards them? So that's where these understanding users input characteristics comes over here, and that's where AI helps us to understand if the tracker is moving towards that, I can able to move this object so that it increases the interactiveness. And the last part is the eye tracking and gaze. So this is one of the classical example where if users we can create design an environment. It could be very useful for UX design of XI environments, because in UI, classical UI, we design our website based on where users is looking. So we start with the important content probably on the top, then we go on the bottom, because when a page loads, users might look at the top. Similarly, we can use this for our XR design as well. So that's where this eye tracking and gaze analysis comes, and that's where machine learning model. So it, because some each people in a 2D space it's limited, but in a 3D space the adds a depth information. So that's where AI comes into play and helps us to understand, and so that we create a very familiar or interesting XR worlds that is adaptable to everyone. That was quick. Then how AI is to support interaction in XR. Still now we try to understand users. Now that we understand users, how do we utilize that information to enhance experience in XR? So there are four ways. One is like gesture based interaction, as we and the second one is locomotion technique. We'll go in the third one is to create a novel devices and interaction techniques, and the last one is haptic feedback. So gesture based interaction, because AR, VR, XR, there is multiple ways to interact with different object here. If you're in a space where I want to have a continuum, if I hold this sticker over here, it should reflect in my virtual reality as well. It should recommend. So to understand where how am I holding this sticker, and am I changing it from here to here, this all should be mapped automatically in your AR application or VR application. So to understand that, how my post body with a minimal input sensor, how we do that, that's where AI comes into play. So certain people looked into a CV techniques where they just capture this video and try to model it either in AR, VR, XR application. Certain people try to look into IMU tracking. So they put some IMU sensors on your hand to understand your gestures, or they use radars to put under the hand to measure the gestures. So it all comes under what kind of input modality for your application that can be accessible, and train a machine learning model or deep learning model, which Leah will be explaining you in later. Then use that for interaction purposes. And the locomotion technique. And imagine in a cramped space like this, and you're using a VR space, VR headphone. The traditional or the most classical way is you have this controller and you can sit it on it and you can navigate through spaces. And that kind of reduces the realism. Imagine you want to walk, and if you walk in VR world, you stumble upon these chairs and things. So if a smarter system is like, it automatically detects there is an object in front of you and there is a space, it redirects the virtual environment where the free space is there in the virtual reality, so you automatically turn without you knowing that there is things. So this is where the redirecting walking techniques, where AI is able to help us improve. This is one of the game changing for locomotion techniques. And the second one is the predictive models or users thing, how users walk during their things can be used to understand their behavior and adjust the whole environment based on that. If they are if you, instead of loading the whole game at the same time, they are trying to go from this building D to building F, it just if you know that it, we can just modify, okay, they are going to enter building F, we just make that building F more like computationally, like just focus on that computational design or interaction space of that building and leave the rest towards leave the behind so that it doesn't hog on resources. So that is also one of the way to use AI. And this is one of the interesting part is to create like a novel devices or things. AI can in a Vision Pro, how many of you guys they try to use eye gaze as a way to um click icons or use icons. They also have where you can use pinch and eye gaze together to tap and stuff. So that is one of the classical AI method that people use for interacting with user icons in VR. And people also started to create like this one is like having a haptic controller behind below your thing, so that it can sometimes give you a feeling of you can adapt its experience based on the thing. If you're drinking water, if something blows out, you can feel it. Or people use it for kissing in VR. So if someone wants to kiss, it gives you a focus more on your lips. So it basically lip interaction. So this is one of the examples, but there are so many examples like this where people use AI and like for making interaction more realistic in AR VR experiences. And the last part is like an haptic experience. I think Anthony is over here. He's the most haptic expert over here. He might share his experience, how he uses AI for his haptic in VR. So people use, imagine I'm holding this one and mouse. So based on the object I'm holding, it can give me the haptic sensation. I'm holding a paper or I'm holding a mouse. Based on that thing. So for this, you need to understand which I'm holding and how am I holding and what kind of surface I'm holding, so that it can give me a intuitive experience for haptic. So that's where uh, haptic and AI can converge and give you a very realistic experiences. And the fourth part is interaction with intelligent virtual agents. I think many of the Allison's lecture covered a lot of this particular part. So basically interacting with virtual agents, the current research is direct one-on-one interaction. Then there's group of crowd interacting with agents. Then there is physical interaction in agents, where agents can understand what is the physical objects that present in your environment and guide you with. And the last one is, can agents gives helps you to improve empathy, or like can you increase trust with these agents. This is the most current research space in interaction with intelligent virtual agents. The first one is like crowd behavior modeling. Like imagine there are people are currently working on, if suddenly a fire broke and we are here, so how does these agents can guide this crowd out of the exit. So it needs a bit of understanding about how people will react when fire comes, understand where the crowd is there, and navigate to the nearest software nearest safety path based on agents based on users location and agents model. So that's where things. And imagine the other way, where you have bunch of npcs and you are there, and all needs to understand different aspect of you. How do you interact? So that's where different kinds of AI agents, and currently a lot of the trend is using multi agents, where you have one agent for uh, uh, tracking your meetings, one agent for giving you contextual environment details and things. So this is where the current research people were trying to build experts of different expertise and combine together. The second part is physical interaction with agents. So because what is the accurate space that agents need to maintain in the VR world? Because there is, after in a horizon or in a space we are meeting, we try to mimic what is happening in the real world. We like to have some kind of a personal space, and this mimics the AR or VR world as well. So that's where agents should understand that. And if you're holding a cup of tea in your real world, it should also understand, okay, you're holding, so this is where that is a way I can't give my handshake to you because you're holding. So that gives a bit of intuitive understanding. That's where AI to help us to understand these things. And the last is trust in AI agents. How can we improve trust? Because that's a serious issue. If you don't trust any intelligent agent, then the user interaction you're creating won't work because people wouldn't use that. So having a trustful AI agents, and people study about it using physiological sensors or uh, using some subjective questionnaires. And the last part is how XR to support AI research. So until now, we try to see forward look where AI is helping XR, AI is improving. Now, how XR is improving AI research. The main part I would say is visualizing AI methods in XR and generating training data, because AI models are data hoggers. Like they need intense correct labeled data or like correct data so that they give you initiative experience. Otherwise, it will be very hard. So the first one is visualizing things. So the models or the AI models that understand 3D environments and understand things, you might want to put them in test. That's where XR visualization gives you a edge. And based on that, even if you want to create a accurate AI model for predicting car speeds and things, you can simulate in XR and generate train a model and try to test it out in in the XR environment before actually implementing in the public space. So that's where visualizing and using XR space to help AI accuracy or improving AI's accuracy. The second part is generating training data. So generating training data is like a very hectic task if anyone who knows like how to create a data set. So we can use XR space to create the synthetic data and use that data to train a model. One of the classic example I would love to show is this. Oops, maybe I'll create this recent work from Meta. So they created like this virtual human behavior to understand robots. So basically they created a bunch of humans in the house, and so that they can train a robot to how to navigate in the house when the humans are there and how to clean the room. So this is where they created a synthetic human simulation data and use that data to train a model and embed them into a physical robots like a Roomba or a dog. Let me go back to my. So these are the current state of the art XR research. People are exploring how they use AI for XR. And now that we know this space, now we have to understand, okay, this is a cool part. This is a cool part. How do we design such intelligent system so that it gives you intuitive XR experiences? So there are multiple ways to design AI systems, especially for XR. One is giving full one is giving full human initiate, like where humans initiate, you just use AI as a tool. Suppose uh, creating a intelligent pen that when users draw it automatically, whenever the users finish and there is a bit of color difference, AI automatically adapts to it. That example I'll show you later as well. Then giving a full AI initiative where human is just an audience, where AI becomes a full creator. And there is mixed part where human both and AI as a collaborator. We should where AI supports human and human supports AI, like a more like a collaboration. So when designing AI, especially for XR, try to create an appropriate level of users autonomy based on this scale, based on your application needs. Then try to align AI with real world behaviors, because uh, with the simulation data and all this stuff, they are simulated and they follow a Gaussian nature and things, or they are, or we can predict them. But real world is mostly unpredictable and their behavior is slightly chaotic. Try to align the AI models you experience with that, and treat it as a treat safety is the most important point, because the users sometimes, as you say, many companies had uploaded their things to ChatGPT, and it can be used by other parties, other users. So that time you lack the safety. It reduces safety of the your personal data. And make sure that you always adapt AI with user feedback, because sometimes the when you try to personalize, giving a personalized experience to a users, sometimes they don't want that better accuracy, or sometimes they don't want AI to take actions. So understand when AI need to take actions, or understand when think, and give a feedback, and create helpful AI that enhances work, because the main idea is it's again a tool that you might be using it. So not all the things needs AI, as Allison. So try to based on your application scenarios or experience, try to weigh that does adding AI adds values, and how much value it adds. That's where it brings me to this kind of concept, where so when automation is needed, replace human with artificial. When most of the time this is what we try to do, like we try to automate everything, but most of the times that won't result in good interaction with users. So always try to go for the collaboration or augmentation, where human collaborating with artificial intelligence, or artificial intelligence helping humans to augment their intelligence, humans intelligence. So this is one of the classical example I can share about the mixed initiative, where human and AI are collaborating. So if I draw small things, first one is trying to understand I'm trying to draw a strawberry. So AI thinks I'm trying to draw a strawberry, and it acts upon it and draws a strawberry. Then I draw another strawberry. Then it suggests a plate. Then it suggests it AI I draw a wine glass next to it. Then AI finds an empty space, it finds and things. So this particular part where I might don't like it, but this is where uh I go with it and draw, pick a color, and it fills out the color. So this is where like it's a fun play about how AI and humans are collaborating. But could be another example where it could be more intuitive and interactive for XR experiences. So I always follow this particular guideline. So I what is the utility of AI and probability of AI being right? So this transition point based on models experience can change everywhere. Maybe I can use this. This transition point changes where AI can we have to understand when AI is a certain probability of certain being right, and when to take action. If AI is poorly, like your model is or your accuracy is pretty less, it's better to take no action than wrong action. And you understand that AI has a bit of a transition point. It's pretty accurate, and this particular uh, matrix or this particular graph changes based on users' experience and AI being right. So we always want where what is the minimal transition point where AI is right and when we can take action. Until that point, it's better to not take action, and otherwise it reduces your user experience in any interaction you're creating, either in XR world as well as real world. This applies to real world applications as well. And finally, if you want to design such AI experiences, there are a couple of thoroughly researched industry guidelines. So try to look at, I'll share these materials later. So my favorite ones is the People AI Research and Microsoft AI Interaction Guidelines that go through detail how to design AI for different use cases, and I feel like which can be most applicable in XR as well. And let me check before I go. So I think let me ask this part. Before we head forward to the tools and frameworks of AI and XR, does anyone have any doubts until the theoretical part? Any doubts? Any interesting finds that on nothing much? Anyone in the online? Did you guys have? Oh, I'm curious. Yeah. Uh, I'm curious how you would be about evaluating utility. Is this perceived or actual utility or from a business and use cases? So I would say the utility is from the actual business user case, because when we develop models based on the perception that it's supposed to be accurate, but the business or user case might change. So it's better to study those things and draw our own utility map versus and AI models accuracy in realistic scenario and follow through the transition plan. So it's just way to understand when we can use put AI to take action and when not to take action. So this gives you that graph, particular graph gives you a classical map to help us to understand, okay, if we cross this transition point, it's safe to say that we can take an action and that will give you promising results. That is way. Josh, does it answer your question? Now that we follow through a bit of theoretical things, it's right. So let's try to get some like what are the tools and frameworks that exist that you can use for your projects for next couple of days. And I'll be trying to go through on a surface level in detail, but if you want to explore in depth, just let me know. I'll be over there and I can come through. You guys share the resources and point towards you to the right direction. And all the documents or the things, everything is linked, and I'll share the slides in the Discord channel by end of the day so that you have a familiar starting point to start. The first one is programming AI tools. So I think if people primarily use Python programming language to code to develop machine learning models or deep learning models, they might follow any of. There are multiple frameworks. These are the most common frameworks for developing machine and deep learning. And Leah will be going through all this in detail. She'll be helping you, guiding you guys to uh, get a data set, train a machine learning model, and output that model. For now, I'll go through the um, easier way so that you can understand or try to develop this. The first one, and there are these are the couple of generative AI tools. Alison shared multiple much, but these are like the LLMs and diffusion models that generates your images, 3D things. There are few options that is specifically for XR. So in XR, if anyone would have worked in Unity, there is a skybox where the user's environment. So this Blockade Labs generates. You can just put a text. I need a Swiss Alps environment. It automatically generates that experience in the scene. And next one is the text to 3D model. There are a lot of models that are coming up where you can just put a text and you can create a 3D asset and import it to your AR VR application, and you can generate music and which you can use it for your AR and VR application. And conversational agents, now it's pretty easy to embed all the conversational agents with this Conway AI things. So in this tutorial, I'll be telling you how to use Conway AI and how do you integrate to Unity as well. And where do you find all these AI models apart from training? The golden hub for all the models or all the spaces is Hugging Face. So all you need to do is, oh, not this one. All you need to do is go to Hugging Face, create a login page or things, click on models, and it has like what task you want, any to any, image, text to text, text to image, and what kind of framework you're thing you need. A large language model, like it has like plenty of options. So if I want text to speech models, all I have to go is like things, and usually let's go with the most downloaded one because of thing. So Coquio XTS is thing. Then you just try to understand how do people use Coquio Studio and use that as your reference and integrate it in your model. It's most of the time it is just importing the API or like importing a model. But I think I'll Leah will cover that in detail later. And teachable machine. So one way, as I said, one way to develop machine learning model is by programming. This is another cool way people worked is you don't need any machine learning thing, but this is only you can develop any CV applications or audio application using this app called teachable machines. So imagine I have to switch off my uh video cam for this experience. uh, I can put a thumbs up over here and record some data, and I can put a thumbs up over here and put a thumbs down, record my data, and um I can quickly add this is thumb down, this is thumb up, and click train model. So that's how easy it is to train a model nowadays. So you just wait for it to train and see, thumb up, thumb down. So you can create this machine learning model easy on the go. And if you want to export it and use it for any of the applications, which I've done in Unity, where I trained a model to detect such poses, then we import it to the Unity. All you need is click this download button and download my model, and it is downloaded already. Now later on when I explain Unity and AI tutorial, I'll share you how we can use this model in Unity to for your AR and VR applications. It's just here, it's a classic thumb up and thumb down information, but people have been using it for audio generation as well, and there's more to come. So this is one of the easiest and simplest way to train a machine learning model. The programming way, I believe the Professor Leo will be sharing you and going through your hands-on. Now I'll get back to my thing. Yes. Then the second part is Google AI Studios. So Google AI Studio, this is also pretty interesting, where Gemini, ChatGPT all have. So this is a currently I found a tool that is very open source friendly, where you can try all the Gemini APIs. All you need to do is get this API and embed for your application, and it can work, to be honest, in pretty time. You can share your screen, and I'm this will stop all the Zoom recording probably. I would but just go check out this Google AI Studio. You might need a Gmail account, and you can start building apps, and you can start talking. You can even show an object in front of you. It can track all these things. And now that there is couple of ChatGPT and things, you can also the current ways you can also run your large language model like GPT or Gemini or Cloud or Llama locally on your PC. And I will go through a detailed explanation in later, where we download up certain local model and run it in Unity so that you can talk to in Unity. But the most common current frameworks are LM Studios and Olama. So Olama is more like a command style. If you're a good programmer, you just use command line interface to generate a API from Olama. You can check out all the models they have and download it. The most user friendly beginner friendly is LM Studio. You go to LM Studio app, download this LM Studio, and it will have this kind of a user interface where it has like a ChatGPT kind of setup, and uh, you can search. You click on the search button. You have all the open source models that you can have, and the current and it also has a where you can use vision models as well. Some large language model has vision ability, so you can use this. So this is pretty friendly and things. And I already downloaded a particular model called Gemma 3N, because all this whole model is one of the good accuracy model. So what I just know is select this model, load this. Like, you can have multiple models based on your system compatibility, and you just load this model, and you can use it as a chat GPT without internet on your PC on the go. Or you can also create a developer API and use, instead of always using ChatGPT or the commercially one, where you might have a where you're restricted with cost and API integration. You can test those API by going to the developer and use that API for your XR application as a reference, and actually improve your experience. Then go think this is the most cost effective way. Currently my system is pretty slow, so it takes so much time to load, but it's a very good way to use large language models locally. Okay, until now, any questions before we go to Unity AI tutorial? Any questions? Any Anyone in online? Did you guys have like any other interesting tools that you can share? Apart from this, do you have any other tools that you use? Notebook LM, that is one of the a good example as well, where you upload your material, it generates podcasts and mind maps based on that. That is a very good example. Any other?
Can I just ask a
Mm,
clarifying question? Before you said downloading that Gemma 3,
yeah.
whatever it was, as like a local chat
Mm,
bot, I'm very new to this. So, like,
mm.
without access to the internet, how does that work?
So okay, I think it's so every model has some kind of weight, or like any AI model you train. So it kind of comes it we export it as some kind of a black box that you can put input, and it just brings you output. Similarly, all the large language models are also have that black box kind of a weight model, that way things. This chat GPT or this UI you see is more like a front-end experience. When I download this whole model, I'll show you an example over here. Maybe okay. Oh, oh no, just a minute, sorry. I need to charge my yeah. Now I know. Uh, oops, that's okay. So this is the post model we trained. So everything is trained like some kind of a, it's saved as a some information where you can access how it's basically a knowledge box, where if you give some input, it will give you output. Similarly for this one, when you this open source models, they when they train this, they export it as some kind of a weights where we can access its information. So here, if I load it like this, I I really don't need any internet things. I can say, hey, how are you? And this is good. I'm doing well. Thanks for. I don't experience. This is a classic example and experience that you get from any large language model. The reason with ChatGPT and all these ones is they are trained on a very heavy data set. They need a big cloud, big computers around the globe to access all the information. These ones are they reduce, they are called small language models. They reduce their knowledge base to a limited one. If ChatGPT has a couple of reasoning methods where it is much more accurate than this ones, but this could be a very friendlier way, local private information. Even you can upload your own information, no one going to access it, because the knowledge boxes stays on your computer, and you're just trying to retrain or based on your experience. So that is how this local large language model works over here. Does
So
that
it's like
answer?
a local database on your system.
System, it's
It's
basically,
online one that's
yeah.
bigger and more open.
Yeah, that is exactly right. You have a local database, local personal storage system, that where you can access information and things. Uh, then, is there any other questions? Any? This LM Studio or Olama, you can go through the website, which also I'll share the links later on today. Just go download. It's like a dot extension files or dot DMG files for your Mac or things, so you can download it, run it on the go. It's a very helpful tool. I've been using it for my whole experience. Then we come to Unity and AI. The reason why particularly focus on uh Unity is this is one of the most uh easy way to create any AR VR XR applications. And if you know how to use the trained AI models like this in Unity, that could save a lot of uh time, and it's easier to implement projects in this one. So Unity AI has been evolving a lot for the past couple of years. It was last year, it was released as Unity AI Centers and Muse. Now they combine everything together and grouped it together as Unity AI. It's just a platform where we can have different interactions. There are three main components. One is AI assistant. That's like your co-pilot or your ChatGPT. Where in Unity, if you remember, you have a physical scene and you have to understand or access objects, and you create interactions in a C# code. So this AI assistant is for that C# code to help you develop good algorithm. Then inside your physical, so I can share, probably it's better way we share. So this is the space this is a classical Unity space. So usually the current AI generators, you can use AI to generate 3D objects inside the space. Initially, what you do is you download or you create your own 3D object and import it over here. Now with this AI model that has text to 3D, you can automatically create, oh, I want a Coke can inside this environment. It automatically generates that. And the last one is AI inference engines. So this is the most one we'll be using today, or you'll be probably using. The reason is the AI assistant and generators, you need a pro access. So for to access them, like as ChatGPT Pro or any AI LLM good models that require. This inference engine is a good one because you can run your own or develop your own machine learning model and run it in Unity. And we'll go through an example where I use the local large language model we use now locally for Unity to develop or speak to it. So this is where the thing, as I said, this the main three pillars of any Unity AI is the assistant, generator, and inference. So AI generates all the images, because anyone who worked in Unity know how hard it is to define the shaders and manage the materials. So that's where AI generator help. AI assistant is similar to GitHub Copilot or Microsoft Copilot, that even ChatGPT, that helps you with generating good code and troubleshooting. And the last one is uh, inference engine. This is where our main current focus is. So imagine in Unity inference engine is, because Unity if, runs on like a frame per second. It's you and your machine learning models are very computationally intensive task. If you run that in frame per second, your system gets toasted. So because of both AI models and Unity system doesn't have a same language. So what we are trying to, so Unity came up with a smart solution where it created this inference engine where it just translates AI models so that you can use it in Unity.
In a runtime environment?
Yes. Yes, yeah, exactly. So the best way for how is it's like creating any web application that has AI in it. So you import that knowledge base or base database into Unity, convert them into a platform that Unity understands. That is called ONNX, Open Neural Network Exchange, and load that model. And you just have to load it once and run it many times. And get the output, execute, and dispose that one. This is more like a computationally, like from a software point of view, where uh, you load the model, you create a memory, then you run the interaction and you dispose the memory so that it won't hog on your resources for a long time, make your so these are my basic experience from my own development, which might be useful. I'll just leave it over here. And default, by default, sometimes Unity goes for CPU or GPU, so you have to specify based on your system requirement either to use GPU or CPU, for because that also affects your performance, as well as you have to train your machine learning model adaptively for CPU or GPU based on. So this is where like you train your like how we train the thumbs up model or thumbs down model. You train your model based on the framework you like, convert that into this ONNX. It's like basically like you have JPEG, you have PNG, you have HEC for iPhone. So it's just a formatting for model weights. So you change all the model weights to like ONNX, which is equivalent of PNG image for AI models. Then you transpile it, run it, and you use it for your application. So this is just an overflow map. So I'll show you a brief example where um, we use that post detection model. So all these codes, don't worry about this one because I have uploaded everything in GitHub. So you can download it, you can run it in your own system and check it out. And if you have any doubts, let me know, because I think I'm running out of bit of time over here. And the basic example I can show, let me bring out the scenes, or still fine, I think. So the post detection model that we trained, I converted in ONNX with a bit of programming that is just you similar to converting PDF to PNG or things. It's just a converter that exists. So you use that to convert and use that, upload it over here, and I'll have my so I'll then in Unity you just create a data set or things. This is like a not a real-time running model. So I uploaded my recent image, then I load it up. It might take uh, it detects the poses that I really want or things based on the experience. So this is one way where you just import the model, load the model, and execute the model. In depth, how does that work is you have time? Okay. I'll I'll quickly brush through this particular part where you use Unity runtime model. You just load it as a model, then create a particular, either you want GPU or CPU, and run the inference, and finally dispose the memory. Just uh, you can follow this flow chart for your example. And these are my another performance tip. You Because sometimes as Unity runs every time for frame per second, so you actually load your model in the start itself instead of your update function. So this helps to reduce the CPU into, so every time you don't have to load, because the bigger the model it is, it takes time to load, so it don't affect your XR experience. Always leverage GPU, do everything in batch and async. So if you want to have a ONNX model database, again uh you can go to Hugging Face, and if you see over here, uh you can just create like models. Where is it? Oh, You click on ONNX. So any model you see over here are automatically in .onnx things, which you can import it directly to Unity. Don't worry, you have to compare things, and it has most of the information. Like if I want to have a image to image ONNX uh, model, there is already one, so you can directly add it to your XR experience and use it. And this is what we saw the post detection one, and I've uploaded the image classification that I use a similar one. Then there is depth estimation, which shows the real time you can capture the video image and estimates its depth. This could be very useful for all the AR experience. And there is a board game application that Unity created. This is more like a reinforcement learning model where you play with a character that adapts to your gameplay. And the last one is LLM for Unity. So this is quickly, I'll go through this one as well. So for LLM for Unity, there's a library that already exists that called LLM for Unity itself. All you need to do is you load that library, or I'll share the GitHub folder. You can choose your model over here. So if you go through the script, you can choose this things. And if you want to download new model, you can add any model. So you have like tiny small models or things, and it already has certain extent. So you can choose based on your computing things, run a model, and I'll just run this simple interaction where the same model we downloaded for the LM Studio, I can use this over here. Hi, hello, who are you? Same answer, same thing. So this is just a way, instead of having this thing, we created our own interface in Unity to have this interaction.
That's just the base project that exists.
You can pick and play. Yeah, exactly. Yes. So this I uploaded everything in the GitHub, so you can use this one to create any project that you're going to work on for this next few days. And you can just the way how do you interact smartly, it's you can use this as a plug and play library that you can for your projects basically. And these are some best practices things. Always start with tiny or low weight models, so that you focus on the experience, then you improve the things. Always for XR experience, try to prioritize latency and responsiveness, because the more it's okay to be a slow to a point, but it's the more slow it gets, the better people lose patience and it reduces your XR experience. And try to follow these guidelines to design initiative experience. And yeah, that's what it practically is. Start small and scale later. Test regularly, test your model, because and all the time your model is going to hallucinate or give you bad experience. Totally fine, because you can reiterate or get users data on the go and retrain your machine learning model and improve its accuracy over time. And this is a GitHub repository. I'll share this document, everything. um, Sorry. The key takeaway is use AI as a game changer for XR. Unity AI and Open APIs are available, so you can use that easily for interacting with things. Try to focus on for user-centric AI experience, and performance and latency too matter. That's why I asked for go for low weight models. And basically that's it.